know. Yeah. All right. Question. Yes. Oh boy. All right. Here we go. This is how you list outcomes. You list them as like a group or a set of groups, right? So you toss a coin twice. You can either have heads or heads and tails. You could go tails then heads, then tails, then tails. Right? Oh my God. Where are you right now? Here we go. The total number of ways this can happen is 4. What is wrong with you? Here we go. There are 4 possibilities if you toss a coin twice. All right? If you toss a coin 3 times, that changes things, right? I would be very organized about this. All right, here we go. So let's go HHH, right? And then just add a tail in one of them. So heads, tails, heads, tails, heads, right? And then tails, heads, heads, right? So just move that T around. True? Okay. Then start with tails, tails, tails. And then we're going to add a head to it. So we go tails, tails, heads, tails, heads, tails. Oh, good. Yeah. It's true. What's the difference? So it's in the order that you flip a coin. So you're flipping the coin 3 times, right? Those are the different things that could possibly happen. Are you okay? Someone got the giggle bugs. All right. Total number of possibilities. 8. It's 8. Oh, by the way, there's a pattern. What if I toss it 4 times?
And I feel like it would be like 12, 16.
Here's why. How many sides are on a coin?
Wait.
What's 2 squared? 4. So 8 is 2 to the
4.
Alright, that's what 8 is. And then 4 times with 2 to the 4th and so on. That's what the pattern is. Alright, so here we go. For the most part though, I'll only ask you to toss the coin 3 times. You just have to remember it's 8. Alright, here we go. Last thing, and then we can do some actual math. Never knew that. Oh god. Here we go. There's a 6-sided die. A 6-sided die is tossed twice. So you could get a 1 and a 1, a 1 and a 2, a 1, a 3, a 1, a 4, a 1, a 5, a 1, a 6. But what if you didn't get a 1 first? Right? You could also start with 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. Right? You're listing the possible things that can happen. Aren't there? Really? Then 3 and 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Right? 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, dot, 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 dot. That's reason we're doing this. It comes 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Hey, Eddie. 36. 36. All right, sir. The 6 times 6, 36. You'll see that number 36 come up a lot. What's that? If it's 3, no, twice. So, in other words, the first one, since there's 2 coins, it goes 2 times 2, then 2 times 2 times 2. For this one, there's 6 sides, so 6 times 2, so 6 squared. 6 squared going twice, 6 squared. Yeah. All right. We good? All right. So, tossing a coin twice, the magic number is 4. Toss it 3 times, the magic number is 8. Toss a die twice. Magic number is 36. All right, keep that out. All right. Go on to the notes where it says probability basics. If you look at my door, it says, if you're read it, the probability of Tigers winning is P parentheses W equals 1. Which means they have 100% chance of winning.
What was that for?
Right. That's for the, well, I mean, no, it was for homecoming. It's for homecoming. Yeah, they did. All right. The probability of events happening. Shorthand of that, you can write like the probability of A. All right. If an event is absolutely certain to occur, in other words, has 100% probability, you have a probability of 1. Right? You cannot have a probability that's greater than 1, and you cannot have a negative probability. So basically, anything from 0 to 1 is your probability. If it cannot possibly happen, then the probability is 0. Yeah. So anything that's between 0 and 1 is an actual probability. You got more than that. Okay. All right. 3. Here we go. Probability is a fraction. It's a fraction. All right. I'm gonna go back here. Yeah. Okay. So for example, you toss a coin once. What's the probability that you get heads? 1 out of 2. Yeah, it's 1 out of 2. Or you can say 50%. Or you can say 0.5. Right? All of those things are between 0 and 1. Okay? Okay. Probability. Again, for something to happen, you want the number of successes, in other words, what you want, over the total number of events. Okay? Okay. So example 2, a penny and a nickel. Those were my 2 kids. Seriously, I got one of them already. Here we go. Her name is Penny. What? I do. What if I get a boy and you name him Nickel?
You go back?
No, I go back. Nicholas? Oh, what if I spelled nickel then L-E-S-S? Like he has no nickels.
Nickel.
No nickels. Oh. Ouch. Oh, moving forward. Here we go. Alright, a penny nickel are tossed once. So this is the same thing as tossing the same coin twice, right? Because you toss the penny, then you toss the nickel. What's the probability that the penny lands on tails and then the nickel lands on heads? So in probability 1, the penny shows heads, and then the nickel shows tails. Or the penny shows tails, and then the nickel shows heads. I skipped one, heads, and then heads, and then tails, right? What's the probability that the penny is heads, right? And the tails and penny is heads. Where is that? It's right here. That's 1 way out of 4 to do it. So the probability of this happening is 1/4 or 0.25 or 25% something. It's truth. It's truth. All right. Here we go. A penny, a nickel, and a dime. That's when I adopt someone and I don't like them. I will call you dime. Here we go. Dime? Nope. Oh, man. All right. So penny, nickel, dime, that's the same thing as tossing a coin 3 times. So basically, what's the probability that you get a heads, then tails, tails? It's 1 out of 8. To get a heads, then a tails, then a tails, if you look at your list, there's only one way to do it out of a total of 8. That's it. That's it. Oh my gosh. Right? Take a look. Oh, you didn't write it down. Silly. Oh. Mer. Mer. You'll catch up. No worries. All right. Example 4. A penny, a nickel, and a dime are tossed once. What's the probability that all coins land on heads or they land on tails? So you want either heads, 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 or tails, tails, tails. 2 out of
32.
what's the total for the coins? It's 8. It's 2 out of 8, which is 1/4. That's 1/4. You have a 1/4 chance. You have a 25% chance of that happening. Yeah. Each of them gets tossed once, basically. So pretend that's like tossing the same coin 3 times, because you're not going to retoss them. Joy? Joy. You reduce when possible. Okay? All right. The word event, if you see it, the word event also means successful outcomes, what you want. Okay? All right. Let's move on from coins to dice. Here we go. An ordinary die is rolled once. What's the probability that it will land on a 2 or a 3? 2 out of 6, dude. It's 2 out of 6, which is 1/5. That's right. Hey, 1/3. An ordinary die is rolled once. What's the probability that it'll be an odd number? 3 out of 6. The odd numbers are 1, 3, and 5. So that's 3 out of the 6 possibilities, which is 1. So this was a bit too easy, I think. Okay, here we go. An ordinary die is rolled twice. What's the probability that both rolls is a 5? In other words, you get a 5 once and a 5 once. 1 out of 36. Dice rolled twice, there's 36 possibilities. So it's 1 out of 36. Right. An ordinary die is rolled twice. Am I going too fast?
No.
Oh, good. What's the probability that the first roll will be even and the second roll will be bigger than 4?
Bigger than 4, that's only one answer out of 5 out of 36.
Plus, second roll is bigger than 4.
Alright, so that's 3 out of 36.
Is bigger than 4. What is it?
Oh, you were 5 out of 36.
So, what's the answer? It's not 5 out of 36. How'd you get that? Are you just guessing? You're just guessing. All right. Here we go. Let's take a look at them. Let's take a look at them. There is another way to do it, and I'll show it to you. But here we go. All right. So you want the first roll has to be even. That would be, let me use a highlighter. Let's count. Highlighter. Yeah. Okay. So that's 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So those are all the ones where the first roll is even. And the second roll is bigger than 4. So we have to cut out all of these. So it's only these 2, these 2, and these 2.
You said the first.
Love. What's up? The second number means the second roll has to be bigger than 4. This is the first roll, and this is the second roll. Right? So based on that, then the probability, oh, let me go over here, sorry. Here we go. Go back to this thing. Oh, there it is. Okay. So we're on this one. So if the first roll is, roll twice, what's the probability that the sum of two rolls is, no, backwards. Here we go. Even. First and second roll is bigger than 4. The answer is 6 out of 36, which is the same thing as 1 out of 6. Right? Another way you can do it. Right? Another method that you could use, you have your first roll and your second roll. I feel like sushi right now. Here we go. Rolls. All right. What is the probability that the first roll will be even? It's 2 out of, not 2, it's 3 out of 6. What's the probability that the second roll is more than 4? It's 2 out of 6, right? 5 and 6. It's 2 out of 6. What do you do with those two things? Multiply. So this would be 6 out of 36, which is 1 out of 6. That's another way you can do it. This way. Uh-huh. No, it has to be bigger than 4. Yeah. That was the rules. Them's the rules. Alright. Uh-huh. So when you're doing probability, you multiply the probability together. If you have multiple probabilities, you multiply them together. Yeah? Okay. Alright. Next one. An ordinary die is rolled twice. What is the probability the sum of the two rolls is 4? So, aka we want 1 and 3, 2 and 2. Is there anything else? 3 and 1. Yeah, that's a different one. That's it. So that right here is 3 out of 36, which is the same thing as 1 out of 8. Right? Those are the only ways that you can add up to get 4. So if you roll a die twice and the results add up to 4, those are the only 3 ways to get it to happen. Roll it twice, yeah. Okay. Hey. All right. Let's move on. Let's move on from dice to playing cards, and that'll be it. Do it. Quickest game ever. All right, here we go. These are notes in case you've never seen a deck of cards before, and it's not rare to find someone who's never looked at a deck of cards. There are 52 cards in a deck. Half of them, sorry about that. There's 4 suits: clubs, diamonds, hearts, and spades. Right? Then you have the red cards, and then you have black cards. So half of them are red, half of them are black. So how many cards are red in a deck?
26.
26. 26, absolutely. All right. Now, the face cards, aka picture cards, a lot of folks count the ace as a picture card. For our purpose, listen carefully, the picture cards are only the ones with an actual face on them, aka jacks, queens, and kings. So do not count jokers, do not count ace, because jokers don't count as a picture. Right? Right. All right. So an ace counts as a non-picture card. Okay? All right. So here's some questions. You're drawing a card from a deck of cards. What's the probability of getting a red jack? So you ask yourself, how many red jacks are there? There's 2 red jacks. Right? Out of how many? 52 total cards. So that would be 1 out of 26. Okay, yeah, 1 out of 26. Okay, let's say you draw a card from a deck of cards. What's the probability that you will get a picture card? Are there 4? There's jacks, queens, and kings. But there's 4 of each type. It's 12. So there's 3 picture cards times 4 suits is 12 picture cards. Over 52 cards total. Do you believe me when I say this reduces down to 3 over 13? Sure, Fluffy. Yeah? Yeah, reduce. I don't know. I've had the answer plenty, so it's all good. Cheater! Yeah. Alright, 3 out of 13. Yeah. Alright, in drawing a card from a deck of cards, what's the probability of getting any black 4 or black 5? How does everything come down to race?
I bet that's a pretty
There we
high
go. How many black 4s are there?
There are 4 black 4s.
4 black 4s?
It's a long tail.
Oh no.
And 2 black 5s, right? A spade and a club. So, in other words, there are 4 black 4s and black 5s put together, divided by 52, which would be 1 out of 13.
1 out of 13.
Black card, there's 13.
No. Only a 4 or a 5. Only a 4 or a 5. Okay, here we go. In drawing one card from a deck of cards, what's the probability of getting a non-picture diamond card?
Alright, let's break down like this.
Okay.
Card.
Right.
What's the other one? Jacks.
Diamonds, spades, hearts, and clubs.
Okay.
Okay. Now, since there's 4 suits, if you divide 52 by 4, that is, it's 13. Take away 3 picture cards. Jacks, queens, kings. 10.
Girl!
Yeah. Non-picture diamond cards, there are 10 of them. Yeah, William? How many picture cards in a deck? Good question. There's 3 picture cards times 4 suits. So 3 times 4 is...
We don't like that.
Right? Which is 5 over 26. Yeah. That's it. Okay? All right. Here we go. These are super easy. I expect it to be done today. Get your practice in so that way you don't have anything over the weekend.
No.
Wait. There you go. Yeah.
That's fun. I can't wait until Thursday. Ready for it?
Rock, paper, scissors it.
It's a white world.
No. That way, Josh.